One and all. So today we are going to learn about another concept in the third unit of software engineering. So the topic name is achieving qualities. So how we will get the achieving the qualities? In the above class we have discussed about quality attributes. What are the system quality attributes? What are those? Availability scenario, modifiability scenario, performance scenario, usability scenario, security scenario, and testability scenario. Okay, now how we will achieving those qualities in general? Okay, now that is the concept here. So here the first one is introducing tactics. So what is the meaning of tactic? Tactic is nothing but a design decisions. So what are the decisions we are taking according to the design? So those called as tactics in general. Design decisions is the meaning of tactics. So we can start the definition of tactics. A tactic is a design decision that influences the control of a quality attribute response. Okay, na? So it is a design decision. So what it will do? It influences the control of a quality attribute response. It influences the control of a quality attribute response. So the response is one of the part of this particular scenario. Okay, na? So what is the 6 parts? Source of first one, source of stimulus, artifact, response, environment, response measure. So this is the design decisions controls the quality attribute response. Okay, na? We call a collection of tactics an architectural strategy. So according to the architectural wise, when we saw, we can consider, we can take the designers means the architects or the designers will take a collection of decisions. So according to their strategy among the particular architecture, that's what tactics. And also a system design consists of a collection of decisions. Yes, once we want to design a system, so we need to take a collection of decisions. Okay, already we discussed according to that particular design concepts in the previous classes. Some of these decisions help control the quality attribute response. Why will we will take this collection of decisions among the design of a system? These decisions will help particular designers or architects to control these particular quality responses. Okay, others ensure achievement of a system functionality. These are major two things to control the quality attribute responses, and another one is to ensure the achievement of a system functionality. So already we discussed how what is the importance of functionality. So okay, now so it's provide the when the system functionality is good, so the it will gives the good results. That is the main thing. Okay, these design decisions, I mean these tactics helps that particular designers to control the quality attribute responses as well as ensure achieving of system functionalities. That is the main thing. And the tactics are those that architects have been using for years. So long years from onwards, the architects are using these type for tactics or decisions, and we isolate and describe them. We are not inventing tactics here, just capturing what architects do in practice. Okay, now we are not inventing them about of the tactics, just we are capturing what architects, who is architect, who are creating or developing a particular architecture, those persons are called architects. Okay, now already we know that architect in practice. So what are the architect will do while architect the particular architectural systems or software architectural systems? So we can see them. So this is the general diagram for tactics. The first one is stimulus, tactics to control response. Next, response. So, whatever the request is comes from this particular user, and whatever it is another attack, it is another fault, it is another failure. So, whatever it may be, it is a stimulus. It is given to the particular system the tactics to control the particular response and gives the results. Okay, that is the response. This is the user, this is the receiver, this is the client, and this is the server. Whatever it may be, it will give the response. That is how we define the tactics. Next, each tactic is a design option for the architect. So, each tactic means each design decision is an option for a particular architect. For example, one of the tactics introduces redundancy to increase the availability of the system. Okay, now some tactics are introduce the redundancy to increase the availability of the system, and also this is one option to architect has to increase availability, but not the only one. Usually achieving high availability through redundancy implies a component need for synchronization. So, we see two immediate ramifications of this example. The first one, tactics can refine other practices. That is the first one. Tactics can refine other tactics, means we identify redundancy as a tactic. As such, it can be refined into redundancy of data. So, redundancy means what? Same data is copied into multiple times. So, already we know that according to the database DBMS also we learn what is redundancy, how to reduce the redundancy by using normal forms. Already we know that. So, same data is copied into multiple times. Okay, now that is called redundancy or redundancy of computation. So, computation is nothing but what in general embedded the control systems. Okay, now that is both types are also tactics. There are further that designers can employ to make each type of redundancy more concrete. So, this is the main thing of why we are using this type of tactics, means design decisions. Next, partners package tactics. A partner, already we know that patterns is nothing but what styles. So, design styles that supports availability will likely use both redundancy tactic and synchronization tactics. So, that is the main use of this type of patterns. So, it will also likely use more concrete versions of these tactics. At the end of the session, we present an example of a pattern described in terms of the tactics. So, according to that first, what are the system quality attributes? Those 6 here also a tactics. Okay, na? That is the first one, availability tactics. What is the first one? Availability tactics. Here we can see what is availability tactics, what are the availability design decisions, that is the actual meaning of it. So, here a failure occurs when the system no longer delivers a service that is consistent with its specification. So, sometimes the failures will be occurred when the system no longer deliver the services, then only the failures will be occurred that is consistent with its specification. This failure is observable by the system's users. Who will observe these type of system failures? Who are using the particular system, who is the end user, those will be observe the particular system's failures. A fault has the potential to cause a failure. So, a fault means what? Is the combination of faults. A fault means not a single fault, it is a combination of faults. Okay, na? Has a potential to cause a failure. This is the combination of faults is potentially is a cause of a failure. Okay, na? Recall also that recovery or repair is an important aspect of availability. So, yes, in general, in natural, the failures will be occurred, the faults will be occurred, but recall that faults and recover or repair the particular faults or failures is an important aspect to the particular availability. The tactics we discuss in this session, we will keep faults from becoming failures or at last bound the effects of the fault and make repair possible. Okay, that is the thing. Next, this is the goal of availability tactics. So, what is the goal of availability tactics? Availability design decision is nothing but when the faults is occurred. So, faults will becomes what? Failures. When the faults is occurred, so what we need to do to control the tactics to control the availability. So, after control this availability, the fault mask it or repair the made. So, compulsory we need to identify the faults, we need to recover the particular faults or repair the particular faults. That is the thing within a time. The above figure depicts goal of availability tactics. All approaches to maintaining availability involve some type of redundancy, some type of health monitoring to detect a failure, and some type of recovery when a failure is detected. In some cases, the monitoring or recovery is automatic and the others is manual. Sometimes these failures, in case we can recover automatically, and others it is manual. Next, fault detection. So, how to identify these faults? How to find these faults? That is called fault detection. So, once the faults will be occurred, so how to identify and how to recover? That is the main motto of availability. So, first we need to identify the faults, detect the faults to recovery. So, this is first one, fault detection. In this first point, ping and echo. So, what is ping and echo? Request and response like the ping and echo. One component issues a ping and expect to receive back an echo, that is request and response within a predefined time. So, within a period of time, within a already fixed some time to request for the request, given the request and response. So, the time is predicted or predefined. So, from the component under security, this can be used within a group of components mutually responsible for one task. Next, heartbeat. Heartbeat means dead man timer. Okay, now that is heartbeat. In this case, one component emits a heartbeat message periodically and another component listens for it. So, one component emits means what ma? Omit, leave cheyadam, problem, heartbeat message periodically, and another component listen for it, another component is listen for it, that is called heartbeat, that is also called as dead man timer. So, if the heartbeat fails, the originating component is assumed to have failed and a fault correction component is notified. This heartbeat can also carry data. So, when we listen these heartbeat by one component to another component, the failure will be occurred, the fault will be occurred, we need to correct the and notify and correct the particular heartbeat. So, sometimes the heartbeat may also be carry data. So, next, exceptions. Exceptions means what? Errors. So, the exception handler typically executes in the same process that introduce the exception. So, next, these are the faults in generally occurs. So, next, how to recover these faults? Voting. First one is voting. So, what is voting? Processes running on redundant processors. Each task equivalent input and complete a simple output value that is sent to a voter. If the voter detects deviant behavior from a single processor, it fails it. So, that is called voting. Next, achieve redundancy, hard restart. Achieve redundancy means what? Hard restart. All redundant components responds to events. Events means messages, whatever it may be, or false, whatever it may be, in parallel. The response from only one component is used. So, usually the first to respond and the rest are discarded. So, first we need to send response to only one component, then we can send to the rest, or otherwise we can discard them. And active redundancy is often used in a client or server configuration. So, we can use this active redundancy oftenly either client configuration or server configuration. Next, such as database management systems where quick responses are necessary even when a fault occurs. Next, positive redundancy. So, positive redundancy means worms restart, or dual redundancy or triple redundancy, not only single, not only dual, triple redundancy also, or the positive response. One component, the primary component, responds to events and informs the other components. So, one component is respond to the particular events or messages and whatever it may be, that informs the other components. So, one component is a response some event, it can be informed to the other component, that is called positive redundancy. It is of worms restart, or it may be a dual redundancy, or it may be a triple redundancy. When a fault occurs, suppose when the fault is occurred, the system must first ensure that the backup state is sufficiently fresh before resumming services. So, it will take the backup, then it will recome before resumming the services. Next, spare. So, a standard spare computing platform is configured to replace many different failed components. So, we want to configure these failed components. So, we can using this standby spare computing platform. So, next, it must be rebooted to the appropriate software configuration and have its state initialized when failures occurs. Next, shadow operation. A previously failed component may be run in shadow mode. Okay, na? That is, okay, sometimes some components are failure previously, they can be run in shadow mode. Okay, na? For a short time to make sure that it mimics the behavior of the working component. Some disturbances will be, mimics means some disturbances will be, maybe it is a sounds, beep sounds, whatever it may be. It can sometimes hang, sometimes we halt, whatever it may be. We are getting different types of problems while using these particular products, systems, architectures, whatever it may be, before restoring is to service. Next, state resynchronization. So, what is the meaning of resynchronization, state resynchronization? The positive and the passive and active redundancy tactics requires the component being restored. So, passive and active redundancy tactics requires the component being restored to have its state upgrade before its return to service. Next, checkpoint or rollback. A checkpoint is a recording of a consistent state created either periodically or in response to specific events. Sometimes a system fails in a unusual manner with a detectably inconsistent state. That is, in this case, the system should be restored using a previous checkpoint of a consistent state and a log of the transactions that occurred since the snapshot was taken. So, once we can take the snapshot, it will be, since it will be occurred. So, that is a checkpoint and rollback. Next, fault prevention, fault detection, fault recovery and fault prevention. So, next, removal from services. The first one is removal from services. This tactic removes a component of the system from operation to undergo some activities to prevent anticipated failures. Sometimes we can prevent some anticipated failures. So, while removing the some components from a system. Next, transactions. The transactions is the building of service sequential steps. In generally, the transactions are the sequential steps such that the entire bundle can be undone at once. So, it's having the sequential steps. Sometimes we can bundle entire the system as undo once, and transactions are used to prevent many data from being affected if one step in a process fails, and also to prevent collisions among several simultaneous threads according to the same data. That is the transaction. Next, process monitor. Once a fault in a process has been detected, once the fault of the particular process is detected, a monitoring process can delete the non-performing process and create a new instance of it. Automatically we can monitoring the and also we can delete the non-performing process and create the new instance of it and initialize to some appropriate state as in the separate tactic. That is the process monitor. We can monitor the process. Okay, now while monitoring the process, we can detect the process faults once. So, while detect the faults, so what we need to do? So, we can delete the non-performing processes and create the new instances. So, that is must and should. That procedure is called as process monitor. So, this is the architecture for this availability tactics. So, what is the main motto of availability tactics? So, we can detect the faults. So, then the faults will be occurred. So, maybe the faults is different types, already we discussed. So, when the faults is occurred, so we need to detect the faults and recover the recovery, means how to recover, preparation and repair. Next, recovery reintroduction. So, next, prevention. So, we want to detect the faults, what we need to do? Ping and echo. Next, heartbeat and exceptions. Next, how to recover voting, active redundancy, passive redundancy and etc. Next, recovery reintroduction, shadow, state, resynchronization, rollback. So, prevention, how to prevent these faults? Removal from services, transactions process monitor. So, while this we can perform the availability tactics to reduce the faults. Next, modifiability tactics. So, modifiability is nothing but what? Changes. We can make some changes and we can test something. We can deploy it within time and budget. So, whatever it may be, we can change something, that is called modifiability. So, how to modify, which type of decisions we need to take, that is called, that process is called as modifiability tactics. So, recall from that, tactics to control modifiability have as their goal controlling the time and cost to implement, test and deploy changes. So, that is called what is modifiability tactics. So, the main goal is controlling the time and cost to implement, test and deploy changes. Next, we organize the tactics for modifiability in sets according to their goals. According to their goals, we can modify these particular tactics. What are these type of goals? One set has its goals in reducing the number of modules that are directly affected by changes. So, we call this set localized modifications. So, what are the changes we will made? So, directly effectively in this particular number of modules. So, that is called as localized modifications. Next, the second set has its goal limiting modifications to the localized modules. We use this set of tactics to prevent the ripple effect. Impact in this distinction is that their modules directly affected. So, and modules indirectly affected by changes. So, automatically what are the changes is occurred, the modules are indirectly affected. Next, a third set of tactics has its goals controlled deployment time and cost. We call this set is differ binding time. This is called differ binding time. Next, localized modification. First one is localized modifications. So, what are the localized modifications we can see here? So, maintain semantic coherence. Maintain semantic coherence. This is one point here. Semantic coherence refers to the relationship among responsibilities in a module. So, that is called semantic coherence. What it will refers? It refers the relationship among the responsibilities in a particular module. The goal is to ensure that all these responsibilities work together without excessive reliance on other modules. It is not depends on reliance of a particular modules. Next, anticipate expected changes. Anticipate expected changes. So, what is the meaning of it? Considering the set of envisioned changes provides a way to evaluate a particular assignment of responsibilities, and it really this tactic is difficult to use by itself since it is not possible to anticipate all changes. Okay, now next, generalize the module. We can generalize the modules. What is that? How? Making a module more general allows it to compute a broader range of functions based on input. So, we can allow the broader range of functions based on input to compute this. That is the meaning of generalize the module. Next, limit possible options. So, limit means what? Some restrictions we can apply. Modifications, especially within a product line, may be far ranging and hence affect many modules. Restrict the possible options, we reduce the effect of these modifications. Next, prevent ripple effects. How to prevent ripple effects? Next, we begin our discussion of the ripple effect by discussing the various types of dependencies that one module can have another. We identify 8 types. What are those? Syntax of data service. Next, semantics of data service, sequence of data control. So, first data syntax of data service, second semantics of data service, next sequence of data control, fourth one identify an interface of A, fifth one local A runtime. Next, sixth one quality of service or data provided by A. Next, existing of A, resource behavior of A. So, with this understanding a dependency types, we can now discuss tactics available to the architect for preventing the ripple effect for certain types. When we follow these 8 steps, we can preventing that. And hide information. So, hide the information. So, means what? Just we can focusing on implementation, not background details. That is called hide information. Information hiding is the decomposition. Decomposition means entire system is going to divide into different units or parts or functions, whatever it may be. So, information hiding is the decomposition of the responsibilities for the entity into smaller pieces and choose with information to make private and which to make public. So, we need to while making them into decomposition, so means we can cut into the similar pieces and choose within information to make what is private and what is make public. The goal is to isolate changes within one module and prevent changes from propagating to others. Next, maintain existing interfaces, how to maintain existing interfaces or communications. It is difficult to make dependencies on quality of data or quality of service, resource usage or resource ownership and all. But in interface stability can also be achieved by separating the interface from the implementation. This allows the creation of abstract interfaces that mask variations. So next, restrict communication paths. So means this will reduce the ripple effect since data production or consumption introduces dependencies that cause ripples. So that's why we can restrict the communication paths. Use an intermediary. The third party intermediary. If B has any type of dependency on A, say either system, A means first person, maybe B is the second person, maybe A is the first system or B is the second system. We can convert them in according to that. If B has any type of dependency on A other than semantic, it is possible to insert an intermediary between A and B. That means activities associated with the dependency, that is use an intermediary. Next, defer binding time. So how to defer binding time? Many tactics are introduced to have impact at load time or runtime, such as following: runtime registration. So first one, runtime registration. So what is the meaning of runtime registration? Supports plug and play operation, that the cost of additional overhead to manage the restriction. Next, configuration files. Configuration files are intended to set the parameters at startup. Next, polymorphism allows late binding of method calls. Next, component replacement allows load time binding. Next, enhanced to define protocols allows runtime binding for implementing processes. So we can use this type of binding times. This is the modifiability tactics diagram. So changes arrives. Okay, now we can change something. So that is called modifiability. We can use some tactics how to modify. Localizes changes we can perform, or prevention of ripple effect, or defer binding times. We want to perform localized changes, so we need to follow semantic coherence, anticipate expected changes, generalized module, limit possible options, abstract common services. So we want to perform prevention of ripple effect, hide information, maintain existing interface, restrict communication paths, use an intermediary. Next, defer binding time. So how to defer binding time? Runtime restrictions, configuration files, polymorphism, component replacement, and define protocols. Next, performance tactics. The goal of performance tactics is to generate a response to an event arriving at the system within some times constant. That is called performance. The event can be single or stream and is the trigger for a request to perform the computation. So here it can be arrival of the message, the exception of a time interval, the detection of a significant change of a state in a system environment, and so forth. The system process the events and generate the response. In generally, the system process the events and generate the response. That is actually what performance. And also the performance tactics controls the time within which a response is generated. Within a time, the response will be generated. And also the latency is the time between the arrival of a event and the generation of a response it is. So that mean time is called as a latency. What is that? The time between arrival of an event and the generation of a response to it. That mean time is called as latency. And this is the context diagram of performance tactics. So event arrives, so process these events and control these events tactics to control the performance and gives the response generate within the time constraints, that is called latency. After an event arrives, either the system is processing on that event or the processing is blocked for some reason. This leads to the two basic contributors to the response time. They are, so once the event is arrives to the particular system, maybe it will be processed or it will be blocked. When it will be blocked, some reason is there to block event, or the processing is blocked for some reason. So whether the processor is busy, so whatever it may be, so that sometimes the process will be blocked by the processor. This leads to two basic contributors to the response time. They are resource consumption and block time. That is called resource consumption and block time. So what is resource consumption? For example, a message is generated by one component. Suppose the message is generated by one component, is placed on the network. Okay, so the message is placed on a particular network and arrives at another component. Okay, na? That is, each of these phases contributes the overall latency of the processing of that event. That is called resource consumption. So one component generate the message on placed on this message on network and arrives the particular message to the another component. Okay, that is called resource consumption. Next, block time. A consumption can be blocked from using a resource because one contention of it, because the resource is unavailable. There the resource is available, here the resource is unavailable, or because the computation depends on the results of other computations that are not yet available. So for example, the one computation is successfully completed, that can be depends upon the another one. So in this situation, the process will be sometimes blocked. That leads to that contention of resources and availability of resources and dependency on other computation. Next, resource demand. So one's tactic for reducing latency is to reduce the resources required for processing an event stream. Next, for that, increase computational efficiency. So we need to increase the computational efficiency by using or by improving some algorithm to decrease the latency. Okay, now next, reduce computation overhead. If there is no request for a resource, processing need are reduced. The use of intermediary increases the resources consumed in processing an event stream, and so removing them improves latency. Okay, next, manage event rate. If it is possible to reduce the sampling frequency at which equivalent variables are mentioned, demand can be reduced. Next, control frequency sampling. Next, bound execution time. So next, resource management. Introduce concurrency. So we can introduce the concurrency. Already we know what is concurrency. It's a parallel processing. That is called concurrency. The block time can be reduced. Maintain multiple copies of either data or computations. Client in a client server pattern or replies the components. That is called reduced concurrency. Next, increase available resources. We need to increase the available resources. Faster processors we need to use, and additional processors we need to use, additional memory we need to use, and faster networks also we need to potential for reducing the latency. So we need to reduce this latency, we need to use this particular available resources. What are the available resources? We need to increase the capacity of those available resources, then only we can reduce the latency. Okay, now that is resource arbitration. So first in, first out. So that is already we know that first in, first out, that is a queue system. FIFO queues treat all requests for resources as equals and satisfy them in turn. And fixed priority scheduling. So we need to give the fixed priority to the each and every process, that is fixed priority scheduling. And we can give the priority order also. So the three common prioritization stages we are also having. One is semantic importance and deadline monotonic and rate monotonic. So with the help of these three we can fix priority scheduling. Next, dynamic priority scheduling. So these are round robin scheduling and earliest deadline first. So these are the schedulings we need to use, that is called dynamic priority scheduling. Next, static scheduling. The cyclic execution schedule is a scheduling strategy where the preemption points and the sequence of assumption of the resources are determined offline. So this is the diagram to perform what are the tasks we need to perform the performance tactics. Events occurs, so we need to perform the performance, we need to apply the performance tactics on resource demands and resource management and resource arbitration. So we need to follow these things to complete the particular performance tactics. Thank you one and all. In this class we have discussed about the availability tactics and modifiability tactics and performance tactics. Thank you one and all.